All right, hello. So we're gonna switch gears today from modeling, and we're gonna start UV mapping. So obviously we have not covered every single tool related to modeling, and you know, I'm sure you've experienced already when you're modeling that, yeah, you run into a lot of issues that you need to attend to. So we don't have time to be covering all of that during the lectures, so a lot of that is up to you to be discovering during the lab sessions and keep building on to your knowledge of experimenting with all the different modeling tools. But we need to get started with UV mapping. So this will just be an introduction to today to UV mapping, what it really is, and how we can understand the correlation between polyspace and UV space. So we're going to use a checkerboard pattern to apply to the mesh and see what might cause some texture distortion and how we can avoid that. Then we're going to make UV layout for the chair, basically, that I did in lecture 2. We're going to UV map that after the break, probably. Then, yeah, just having a look at some concerns. Sometimes the UVs can become flipped. We don't want overlapping UVs per object, but sometimes we can have overlapping UVs for multiple objects. So you have multiple objects sharing the same texture. Yeah, so it becomes a little confusing, maybe. So we're going to try to just work through one asset like the chair, and I think that that's going to help clarify things. And then we're just going to export the UV layout to Photoshop and just make a simple texture, just a color texture. So that's basically also what I want you to do in the lab assignment. So you're just going to UV map the chair you made or another simple hard surface asset. Yeah. So what I don't recommend is tackling any more advanced meshes. Like, well, we haven't really made that many, but any like the ones we started subdividing. Let's rather look at that next week. So we're going to look at another software called Hedis UV Layout, which is another software that only does UV mapping. So it's actually very efficient for unwrapping slightly more complex shapes. So if I do Google searches UV pattern, you're going to see a lot of these checkerboard-like patterns. Some of these are kind of creative. you Basically, a lot of them have checkerboards, and then they have either numbers or letters. So the numbers are there to primarily you can see if the texture is flipped or if it's the right way. And the checkerboards are there to see if there's any texture distortion. So this, I think I have this one probably. Or yeah, let's just download it. So this is a little 512 one, so that's nice. Can I have it? Yes. Oh, and you're on the server, so that's good. So for anyone who hasn't tried it, this is the server. Just type in this and you're good. Where did that go? Did I save it here? Okay, no. Oh, there it is. Okay. Yeah, so I'm going to make a new project file. Oops. And let's put this in the source images directory of that project. And I'll do, yeah, so let's just make like a plane. And again, I'll turn off the interactive creation. So, yeah, just a standard polygonal plane. Don't really need the divisions. So you see the components here. We have the edges, the vertices, the faces, and here are the UVs. So that's another component type. So we can select the UVs from here, right? But if we just select the UVs and we try to move them, nothing happens. So in order to move the UVs or do anything to the UVs, we have to go to the UV world, which is in the UV texture editor. So it's under Window, UV texture editor. This one. So you can navigate in here just like in the worldspace, just hold Alt and right click. But obviously we can't rotate around because there's only 2 axes. So what we're looking at here is the UV space. So it's maybe hard to see, but this is the plane right here. So it's represented in this top right quadrant of this coordinate system. So if I right click, I can see that I can also select edges, vertices, faces, and UVs from here. So let's select UVs. I'll select all of them, and then I can move them around. So there you see there's the plane. So all the polygonal primitives, they have UVs already assigned. So just some random UV pattern. This one incidentally is just a plane, so it just fills this 0 to 1 quadrant. So the top right quadrant, this is the one we're going to be using when we're doing the UV layouts. So when we're working with UVs, you can be anywhere, it doesn't matter. So all these UVs extend sort of infinitely. You can just have, well, not infinitely. When we're working with multiple UDIMs, when we have multiple of these, we do like 10 horizontally and then 10 vertically. But that's if you need a lot of resolution. So it's not practical for our purposes. We're going to be fine pretty much sticking to this one, 0 to 1. But the UV space extends, you can keep working wherever you want, and then just finally when you're happy and you're making your final UV layout, you make sure that all the UVs fit precisely within 0 to 1. So that means they can't be slightly outside 0 to 1 because that's going to cause some issues. So, okay, so then we're going to get back to that. Okay, so what's happening? Let's grab that little checker or that little texture that we found. So I'm just going to make a shader. Right click and hold, and I can do a surface shader. Well, let's do a Lambert. And then the color, I'm going to grab this. I'm going to click a file node. I'm going to turn off the filter type on the file node. I don't need it. And I'm going to grab the checkerboard pattern. So there it is. And press number 6 to see it. So this would have been assigned perfectly if I hadn't moved the UVs. So you can see now it's not really perfect because the UVs are moved. But if I try to nudge that back, you can see that this checkerboard pattern just fits perfectly in the 0 to 1. And that's that. Okay, so there's this little button. You can toggle on and off that little face. You can toggle on and off the underlying image. Or you can also grade out this one. So what you'll see here, if I move the UVs, if I start moving the UVs over, you can see that the texture doesn't disappear. It just continues. So if I move it precisely 1 unit across, which is actually this button right here, I believe if we set this to 1, it's going to translate the UVs precisely 1 UV region over. So if you take a look at the texture, it doesn't change at all. It just stays the same. Also going up. All right. So you can see that we're moving the UVs around. The underlying texture is moving around. So in other words, we're seeing applied whatever this region, whatever the UVs are over, right? That's the texture we're seeing. So if I have all the UVs here and I press scale, so go to the scale tool and I scale it down. I can even scale all these UVs down and move them, scale them down. So now all the UVs for this plane are just inside that little number 6. So that's the one that covers the entire plane. So the UVs are actually independent from any set texture resolution. So with any kind of UVs, you can apply whatever texture resolution you want. So this checkerboard, incidentally, has a 512 by 512 pixel resolution, which is what we mentioned, I think, last time. It's one of those very common texture resolutions. So it's just doubling up from 2, right? So 512 is half of 1K, 1024, 2048, 4096. So that's a very common resolution. It's just, you don't have to use those, but it's just to keep things running smoothly. We want to make sure we optimize all the data. So that means that, well, you can, if anyone of you want to do the math, that means how many of these do we have? We have 8, right? There are 8 little checkers, so if you divide 512 by 8, you can figure out the exact texture resolution for this one currently, right? Because now all the UVs only make use of 1/8 of the resolution. Since the resolution is 512, you take 512 divided by 8, and you can find the exact current resolution actually for the mesh as far as its texture. So that's what we call the texel density of the mesh. So if this also becomes something to be aware of, what's the actual resolution of the texture as it appears on the mesh? Because if we have multiple objects in an asset, and especially if you have a huge scene and you have multiple assets, and in all of those assets there are multiple objects, okay, so this becomes complex. And you have to be aware, and you have to figure out, you have to be able to discern the, don't ask me again. You have to be able to discern the texel density of all the objects in your scene. Does that make sense? This is to make sure that you don't have like a really high res asset right next to a low res asset. Like, it doesn't make sense. It's going to look strange. You can go very close on one of the assets, but then the other one is going to look pixelated, right? Anyways, so this also means, of course, that when we're UV mapping, when we're making the UV layout, we want to make sure that we make as much use as possible of the 0 to 1 space. So whenever we're leaving empty space inside of here, it just means that it's wasted data, right? So even though, yes, we're loading in the 512 image, if I only make use of this little quadrant, we're loading a lot of unwanted data, but we're still loading it, right? So, but we're not making use of it. So for the plane, of course, what we had is actually the obvious solution. It just fills the entire 0 to 1 space. One thing you have to be careful of, actually, when if you just use the plane's UV solution, is that the UVs are actually on the borders, which is a problem usually. So, like the borders being the borders of the 0 to 1 quadrant. So if you're doing like displacement maps, sometimes if you want to be doing more CG, there's lots of things that could cause troubles having the UVs be on the borders or extend the borders of the 0 to 1. So I would just go like, this. Just make sure they're inside. Also for like light baking, for those of you who want to be doing games, that could be an issue. Okay, so let's grab one of the UVs up here, and let's start moving it. So now we no longer have a perfect representation of what this polygon looked like over here in the UVs. We're intentionally causing distortion. That's texture distortion. The reason always is that there's no longer a very nice relationship between what the actual polygon looked like in worldspace. This shape should actually look the same in the UVs as much as you can. So that becomes the trick. Like when for a plane, it's not a problem at all because it's a flat surface. So it's not a problem presenting this flat surface over here as another flat surface. But whenever you have a 3D model, the trick becomes making a 2D version of that 3D model without introducing texture distortion. And yeah. So, is there any questions just about this? Like the relationship between the poly space and UV space? No questions? Okay, so let's look at a cube. So you can see also when I rotate the cube or do anything to the cube, even if I move its vertices, the UVs will not update. So if I assign let's just assign the same Lambert. So now it has the same texture applied. So this is obviously another way to introduce texture distortion. We're changing the polys, but the UVs are the same over here. Let's turn off the underlying image. So this is just a display thing, right? You can turn it off. It's still under there. It's just you can't see it here in the UV texture. It's the same thing. There's no longer a nice match between what the polygon looks like and what the UV looks like. So if I move the vertices like that, you can see the UVs don't update, and if I move the UVs over here, you can see the poly doesn't update. So this is why we model first. So you want to make sure you have a nice mesh, you're done with the model, and all the polys are done before you start UV mapping. That's the right way to do it. Because sometimes I see students would model something and they apply a texture, and then you try to nudge the UVs to match the texture, which is not really what you want to do. So before you start texturing, first we model, then we UV map without thinking about the texture. So the only texture we use now is a checkerboard, just to see the distortion. Okay, so why are the UVs arranged like this? There's not really a great reason for it. It's just, this is just the default layout for the Maya primitive cube. It just looks like this. I can move it around. So all these UVs, obviously we have 6 faces. There's 6 faces to a cube. We see all the UVs are connected. So if I grab one of these, I can actually control. If I control right click. So in Maya, if you control right click, you can change the selection to become another type of selection. So if I select one UV, I can control right click and select the shell. So now it selects all the continuous UVs. So a shell, or a UV shell, is just a selection of continuous UVs. So since all the UVs are just one shell for this entire cube, I can move this whole guy around. So there's actually a tool here as well to do that thing, this one, which is Move UV Shell tool. So if I just click this, I can select anywhere on the UV shell and instantly just move it. Okay, so why would I want a UV layout looking like this? You can see the downside of having it look like this is that it might be hard to make really good use of all the space here inside this quadrant. You can see that there's a lot of unused space. And I can't really scale it up anymore because it's as big as it will go. And in fact, I would scale it down a little bit because I don't want it touching the border. Maybe I can have it larger if I try, make a diagonal or something. No, not really. So with this current layout, it's not very optimized in terms of space. Like I'm wasting a lot of the space. One of the things that's easier with this kind of layout, you can see that these 4 faces. So if I go to face mode here in the UV texture editor and I can select the faces, you can see that these 4 faces are together. If I go to number 4, actually it's not very, go number 5. You can see that that's the continuous face path. So depending on the texturing that you're going to be doing, you can imagine that if you have a continuous UV shell like this, it's going to be easier to achieve like a continuous texture running across this face path. Does that make sense? Like if this were to be, yeah, anything that's like a continuous texture. If it's a tire or if it's anything, you can imagine that's a continuous texture. It would be easier if the UVs actually were to be aligned like this. Right. So that's the sort of logic that you have to apply when you're planning out the UVs. But technically, it doesn't really matter. So technically, what I could do is just, let's now go, I'm going to go to the edge mode. So what I'm doing is I just click Q, so I go to the selection tool, right? So I'm in the selection tool, and I can go right click edge mode, and I can select these edges. I believe if I open up the poly count, yeah, so it's one edge. But I can also, over here, actually, yeah, let's see. Okay. So this is in the UV texture editor. If I want to separate these UV shells, or these UVs, I can select that edge and go to this one, which is separate the UVs along the selected edge. If I go back to this tool, which is select move UV shell tool, I can now see that there's 2 UV shells. So I can keep going. I can just grab this one. So I keep just, if I select all of these, click this one, I have cut everything apart. So then if I wanted to do something like this, where I keep placing these, you could make some sort of pattern. You can see now there might be easier to have at least a slightly larger texture resolution. Okay. Let's look at the texture. So, the underlying checkerboard really just there to see if there's any distortion. If there's no distortion, this is good. So the cube being one mesh, like one continuous object, like one mesh, we don't want these UVs to be overlapping. So that means, I can do that. I can place this one here. Now the UVs are overlapping. You can see that the move UV shell tool is preventing me from doing that. So that's nice. So we can actually go into the move UV shell tool and turn this off. You don't have to do that. And then it will allow me to place it over. But you might just leave it at the default. Sometimes it's kind of nice to be able to place them really close. So that's why some. But let's just keep the prevent overlap. Yeah. So if you have overlapping UVs in one mesh, it can cause some problems when you're baking. So if we're not going to be baking, actually maybe a lot in this course, but if you want to have normal maps, displacement maps, all of this, again, this is one of the issues that typically, yeah, happens. Okay. Questions? So how many UV shells do I have currently? 6 UV shells, right? And the logic here is really technically doesn't matter. It's just up to you in terms of what do you need to actually be continuous shells. And again, the logic is if you have a continuous texture, yeah, it's easier if you have a continuous UV shell. So here, I could connect these. So these are like placed randomly right now. Okay, so this is actually a good little thing to point out. So these are just placed randomly. I didn't really pay attention to which is which or which way they're rotated. So when I select this edge or this edge, trying to connect these, you can see that no, this edge is actually down here. Then I can say, okay, well, where's this one? Oh, that one's actually over there. So, okay, so if I wanted to connect these, I could move this one over here. I can rotate it. And I can see, again, yeah, so these are the corresponding edges. So it seems like there are two edges, but they're actually they're the same edge. They appear twice in the UVs because the UVs are split. But in actual fact, it's one edge in the mesh. It's this edge. So then I can move this out of the way, I can move this down. Then I could select it, and I use this tool. Move and sew it together. That will connect it and merge it together. And if I select the Move UV Shell tool, it's going to move this way. So this one is down there. Okay, move it up, rotate it, connect it. This one is over there, so I'm not gonna. Okay, so I'm not gonna connect using this edge because this edge would have to be connected over here. Maybe I can use this one. Then I'd have to grab this one. And let's see. So I'm going to use this one. So I don't. So if I can't use this edge because that would connect it here. Can't use that edge because that would connect it there. This one has to go there. But one of these will fit into this one, which is this one. Right. So I'm going to grab this one. I'm going to rotate it around. And there we go. This should fit here. And sew it together. So the only thing I've achieved is that now I have two UV shells. Technically, doesn't matter. Same thing, it doesn't matter. The only thing I've achieved is that now it's easier for me to draw a continuous texture along here and here, if you needed to do that. Which is the only reason we actually have to make continuous UV shells. So, you know, it's a good practice being able to draw or being able to make large, nice looking UV shells, which becomes, depending on the complexity of the mesh, it becomes increasingly difficult. It matters less these days because we can also, when we texture, we can also 3D textures. You can paint directly on the mesh. But it's still very valuable to have good UVs. So typically you take the time just to make nice shells. Question? You don't know. You don't necessarily, depending on the software you use. But, so for instance, in ZBrush, you can do something called poly painting. So it actually assigns an RGB value to the vertices, and then you can transfer it to whichever UV map later. But for a lot of texturing solutions, you do need UVs before you texture. But that's, yeah, so that's nice if you're doing ZBrush. You can poly paint. You don't need UVs. Yeah. But you know, and there's like PTEX, which is Disney's thing. They don't really. The thing is, UVs are actually pretty good. They're pretty great because it's such a nice thing being able to export images. So there's been lots of different solutions, but I think now with you can also use like multiple UDIMs, which is if you have a really large texture resolution, you can have hundreds of or 100 UDIMs, which means you could have like a texture resolution of 8K times 100 for one creature, for instance. So, which seems to be the preferred way of doing things right now. So, UVs are pretty cool, you know. Yep. All right. So, any questions about this? So if I grab this one again, let's detach it again. If I start scaling this one, let's figure out where is this. So seems to be that one. If I scale it down, I'm obviously introducing a different resolution for this poly. So no longer do we have a uniform texel density for this mesh, which is typically something you never want. It means that I can observe this mesh at this distance, but if I go over here, oh no, it's very pixelated, obviously. So that's another thing. You really want to make sure that you can also use the checkerboard like that, like to see, well, how large does this need to be? So you can line it up using the checkerboard. So that's not really a rocket science dead-on accurate thing, but you can sort of get it pretty good. So you see here, and yeah, a little bit larger or smaller. There you go. There. Right. So now they're relatively similar, and I could attach it back. Okay. Yeah. So when we're let's okay. So yeah, you can't really. I don't think you can snap. You can't really snap like this, like holding V, which would be nice. You can't snap the UVs like that. But if this one is down here and I needed it to be aligned with these, I can use these tools. So this one is like, it aligns the bottom ones to the top ones like that. So being that this one was the only one down here, and these ones are aligned, it's gonna align everything up. Oops, select all, and it will be aligned to these. So, and if it were over here, I could use this one. Yeah. Let me repeat your question. If you scale the UVs down, yes, it will affect the actual resolution on the mesh, right? What do you think is going to happen to the resolution if I scale the UVs down? In what way? More? It's actually going to give it less, right? Because mm, okay. So the logic here is that within this 0 to 1 space, right now there is a texture applied that's 512 by 512 pixels. So if I scale this one, if I can fill that space as much as possible, I'm using as much as I can of that resolution. But if I scale it down, I'm using much less. So if I scale this down, like I was saying initially, if I scale it down like to one of these little, like now I can actually be pretty exact. I can say, well, this is 512 divided by, what is it, 8, 10. 1, 2, 3, 4, 5, 6, 10, right? Divided by 10. Then that's like, what is it, 51.2. Which would be the actual resolution for this polygon. Or no, for all of them. Let's see. So yeah, so if I grab one of them, I detach this one. I scale this one down to fit inside one of these little squares, which is exactly 1/10 of the entire 0 to 1 space, which makes it, right now, since I'm using a 512 texture, precisely 51.2 pixels. So I know that right now the actual resolution for this polygon is 51.2 pixels. And that's the current texel density of this polygon. There is also, like, so that's the thing, you have to make sure you have a uniform texel density. So not only for, right now it's just a single mesh, but usually it's a whole asset with multiple objects, and it's supposed to exist in a world that has other multiple things, and it's not really useful if you have a really different texel density. Like if you place your hero character next to a low res environment, it's going to look crappy. So it needs to be sort of the same. Otherwise, you're also losing data again. Like you're not, yeah. Right. So just keeping things optimized. So yeah. So your question, yeah, if you scale it down, you're actually introducing less resolution because we're using less of the space. So the thing becomes, we really want to make sure we use as much as possible of the 0 to 1 space. So if you were to estimate the current texel density, like the current resolution, we could do that as well. So you'd have to like just do a simple math. You'd see that, okay, well, it seems like each of these faces, like this one, like it covers like a little over 3 point something of these ones, right? So we can estimate the exact texture resolution per poly. Yeah. Mm-hmm. Yeah. Okay. All right. So this is a good point. So if you have a huge object, right, and then you have a lot of more faces, meaning you have a lot more UVs, you have to scale everything down to fit inside the sort of one. Yes, you're going to lose quality if you're using the same texture resolution. But then I could up the texture resolution. I could do like a 1024 or 2048, 4096 or a 4K texture. So the UVs are independent from texture resolution. Right now, this checkerboard is 512, but that's just random. I could have found a bigger one if I wanted to. It doesn't matter. So we're not making the UVs for a specific resolution. We're just making sure the UVs are optimized. You're making use of much of the space as possible. There's no distortion. There's no overlap per object. So I can't place this UV shell over here. I don't want to do that. I don't want to have overlapping UVs per object. We can have overlapping UVs for multiple objects in one asset. So we're going to look at that after the break. And I want to make sure they're all inside the 0 to 1 quadrant. All right, so let's take a 15-minute break. Okay, so we made this simple UV layout for the checkerboard pattern. So how do we get this out of here, and what's the point? How can we start texturing? So this then becomes the layout that we're literally going to just take into Photoshop, and we're going to be able to texture knowing where the UVs are. So if I make sure to go to object mode, so I'm in object mode, I select the object, and I can go up here to the polygons menu, and I could do a UV snapshot. So UV snapshot is literally just a screen grab of the 0 to 1 UVs. Oh, some of you might have tried the PSD networks and things like that. We're not going to be doing that. So there is a way to make Maya link up with Photoshop, and then yeah, it doesn't really work very well. So there's typically a lot of issues regarding blending modes. So if you use blending modes in Photoshop, they don't really translate well into Maya, and it's not really a good way to go about this, I think. So what we're going to do is just going to make a UV snapshot. So go to polygons, UV snapshot, and it's just going to ask you where do you want this, and it's going to put it in the images directory of your project file. So this is my, my cube UVs, and this is really just a reference, just a layout. So the resolution I put here doesn't necessarily mean that I'm limiting myself to that final resolution. But let's just try to do a 2K texture for this. So it'd be might as well just do the layout in 2K. So 2048 by 2048. I'm going to change this to just be like a JPEG, so I can open it in Photoshop. And you can see the UV range in which it's going to snapshot is 0 to 1. So that's what we've been talking about. That's the quadrant we want. So, okay. So sometimes this doesn't work, and usually the reason it doesn't work is not that you're not in object mode. So you want to make sure you're in object mode, you select the object, then you go to UV snapshot. So now I should find it, in that directory. So in the images directory of the project. So if I just open that in Photoshop, this should be just a 2048 by 2048 normal 8-bit JPEG. Great. So that's a good start. So in Photoshop, when you open a file like this, this layer will be locked. So what I usually just double click here, and you can name it something if you want. So UV layout. Okay, and then that also unlocks it. So now I can alter it if I want. So this is it. So let's just try this. If I make a new layer, I can place it underneath the UV layout. And let's just do something. So, you know, let's have some colors. Okay. Let's see, screen. So, yeah, I don't know if you've tried all these blending modes in Photoshop. So, essentially, these ones relate to multiply. They're kind of like the multiply. These ones relate to screen. They're kind of like screen. And these are opposites. So if I try screen, you can see that the black disappears and the white appears. And conversely, if I had set it back to normal, if I invert this and I hit multiply, you can see that the white disappears and the dark shows. So it's just an inverse multiplication, meaning that whatever, yeah, so we'll get back to this, but for now, we just need to set this layout to blend mode screen so that it really is just on top to show us what's underneath, and we can also see where we should paint the texture. So if we try something here, hey, and there. So great. So this becomes the texture. So now I can save the Photoshop documents that I'm working in. So save as just a PSD. So you can leave that wherever you want, in data, or I typically also just leave the Photoshop document in the source images directory. So even though I'm not going to be connecting the PSD necessarily to a material, I just like to have it in here because then when I write new files out of that PSD, it's just going to go to this path. So cube PSD. So this is my working document where I will be doing all the texturing for this cube. So I want to include the layers in the PSD document, and fine. But the PSD is not what I will be connecting to the material. So now I need to export another file, which will be the color. So I can remember to turn off the layout. Otherwise, this pattern, I don't need that in the color. This is really just for me to be able to see what I'm doing. So down here, it doesn't matter what I do. None of this down here will show up. And you can see I also extended a little bit outside the UVs. This little yellow part will not show up on the poly. Okay, so let's turn off the layout, and I'm going to save this out as some sort of image file. We could do JPEGs, we could do PNGs, we could do TIFFs or Targas. So TIFF and Targa, these are more like lossless formats. They don't do image compression. They can, but they don't here. So typically, if you TIFF, I use TIFFs a lot, Targas as well. Sometimes I use JPEGs. The JPEG compression is actually very good. You can't really. What you don't want to do is save a JPEG or a PNG and then open those formats and change something and save another JPEG or PNG, because then you're you're introducing that compression twice, so you have a generation loss. So, but that's anyways not what I'm doing, because I will be doing all the changes within the PSD, within the Photoshop document, and just saving out new JPEGs or new PNGs. In that case, JPEGs and PNGs are totally fine, and they're perfect. You can do wonderful things with using those. So it's not, because sometimes people think you have to use these. No, not necessarily. So cube. So we're gonna do just a basic color map. So you can call it color. Some people call it diffuse or albedo. So we'll get back to all these terms, but for our sake, we can call it color. Let's see what's I forget for the Lambert. I think it's diffuse, right? Oh, it's color. So we can this just depends on your naming convention. We can call it a color map, which is that's it. PNG. Let's see what happens. Save this out, and okay. So the PNGs take a little while to save. Now it's done because it has to do that compression. So then, yeah, I can make a new material. Let's do a Lambert again. So I'm just going to call this cube shader. I'm going to attach a file node again, turn off the filter type, and do the cube color PNG. There it is. So you can see the one that I kind of missed at the bottom. See, that's sort of extending beyond that poly because it's extending beyond the UVs here. So if you take a look at the underlying image, so if I open up the UV texture editor, there it is. Same thing we're looking at over here. So, all right. So we're just gonna texture this very quickly. Just throw in some photo references of texture. So textures.com is a pretty nice resource. It's free. I think you can also pay, and then you get more. You can download more. But what's that? Yeah, you can get really large ones. So let's just find something. So okay, so when you're looking for texture references for color maps, you can see that a lot of these are kind of dull looking. They don't have a lot of highlights or shadows, or they're kind of flat. And that's what you want. So because like you see this one might look interesting with this lighting, but you don't want that reflection in your diffuse map or in your color map, because that's actually, you want the shader to do that, like the highlights and everything. That's not something you want to have baked down in your color, obviously. So we're trying to stay away from having any sort of highlights in the color. So these might not be, so this one could work, right? So, right, so you can see, yeah, actually I have to log in. So you have to sign up for free. Let's see if I remember mine. I might not. Let's see. Oh, yeah. Okay. Wonderful. But yeah, so this is free. You just sign up and you can download some per day. Except some of these are only for premium. Or you can go outside and take your own references. So see, this might also look interesting. So let's have a look at this. Because you can see there's a lot of variation, and you might like the way this looks, and that's fine. But there are some benefits to actually building up that these nuances, like there's some benefits to building that up yourself using Photoshop and blending modes and things, because then you have all these things separated, so it becomes easier. We'll get back to that. Yeah. So I don't know. What do we want? Let's see if we can find like a crate. It might be cool, like to do a little crate. Yeah, so let's do this one. So I typically just like whichever the largest one I can get. Yeah. So just gonna. So obviously, if you go on the server and we make like a common texture library for all of you, and then if you download some textures that you like, you can put it in that folder, and then all of your group will, or all of the class will have a joint library. So that, if you want to help each other out a little bit, that could be a nice thing to do. If you download a premium thing, or you can also find a lot of texture libraries on CGPeers. Okay, I'm recording this. I will bleep this out of the recording. CGPeers is like Pirate Bay for CG artists, which is really great. You can find a lot of things. Yeah, it's illegal. All right, so yeah. All right, so cargo. Let's see. Yeah, so CGPeers. Wonderful. Yes. So there we go. Okay, so yeah, whatever. Let's not spend too long on this, but I'll double click here and let me just grab this. Go to the selection tool, and I can grab this. We would spend a little more time making sure this looks right, but let's just throw this on the thing. So Control C, I can copy whatever's in that selection, and Control V, I can paste it into here. So since my document is only a 2K, I have to scale this down. So okay, I'm pressing Control T for transform, and then I can hold Shift and scale at the diagonals. So that will make a uniform scale. You can also enter it numerically here. But let's see what we get. So yeah, okay. So this is going to look horrible, but whatever. Let's just be done with this one. So I want to copy this layer, and I want to move it over. So there's some ways of, I can hold Alt and Shift. If I'm in this tool, like the Move tool, I can hold Alt and Shift, and that will just drag instances of that layer. And then I can select, if I want to, I can select all these, Control E to merge. And I just merged all these together. So this is completely random, whatever, this is fine. So they're in the layout. I need to remember to turn off the layout when I save the color map. So I'll go to PNG, and I'll just override the cube color PNG. So this is what you want to do, like if you're making changes to the color map, you just go back to Maya, and then you find the, so if you have this one open, for instance, you can just click here, reload, and that's going to reload that image. So if you're in here working, you're making changes, doing anything, click reload. I think there's also a reload here somewhere. Maybe not. Yeah. But it is in the, yeah, you can use this one. Anyways, yeah. So, questions? Yep. Yeah. 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 So you could. The reason I don't want you to do that or get used to, you can, but you. So there can be issues with baking. So if we stack all these on top of each other, we have one object with a lot of overlapping UVs. So I typically stay clear of that. Uh, yeah, yeah, for baking purposes. Yeah. So now these are all the same, right? I mean, if you wanted a really optimized in-game little crate, yeah, you can do that. You have to be mindful when you're doing it, especially, and it will cause some issues baking. So it just creates a little more trouble. But yeah, you can. So we could have all these sharing the same little texture all the way around, and that would be more efficient in terms of texture space. Typically, probably we want some of these sides to be a little bit different. Uh, yeah, I'm done with the crate. Oh, yeah, sure, go ahead. Yeah, so if you select the face, you can see it's selected here. If you select this face, or you can also do it here. So where is this? Oh, it's here. Where is this? Yeah, yeah. So select them from here, or yeah. But you have to be in Maya, yeah, probably to figure it out. So then, we could have 100 of these, and we're not adding any more texture resolution. We're using the same little guy. We're doing a big warehouse. Beautiful. Okay, let's quickly mention tileable textures. So tileable textures are typically very useful. Well, they're generally very useful, but typically for large surfaces like this, like the floor. So it wouldn't make a lot of sense trying to attach a huge texture to fill this entire floor. It would be very inefficient. To achieve the same resolution as this one would probably, depending on the size, we'd have to use a ridiculously large texture. So that's why we can sometimes use tileable textures. So if we go back, or yeah, they're also called seamless. Yeah, show seamless only. That's nice. So whatever. Let's just quickly find something. All right, for the sake of simplicity, right now, let's just do a one by one quick little thing, and we'll do a strange wooden floor. Hmm. So, so by seamless, it means just that. Like you won't be able to tell where this image ends. Uh, so by looking at it like this, it's not really apparent. But there's a way in Photoshop to actually push the sides of the image into the image. So if we go to Filter, Other, Offset, you can see we can actually offset the image horizontally. So right now we're pushing the side of the image into the image and also up and down. And as you can see, we don't really see any seam. So you can also make your own seamless textures this way. Like if you open any image, so, I'm just going to mention this very quickly in case some of you want to try that. So if you grab any sort of, like this one, beach. Maybe these are probably seamless already. I don't know. What happened? All right. Yeah, it's probably probably seamless already. So that's nice. This is a beautiful texture. Let's make it not seamless. So I could just like, if I crop it, let's say. So, yeah, so just make it like 50% smaller or something. Canvas. And then whatever. So now it should no longer be seamless. So when I do this offset thing, you can see that now we see that seam, which is typically what you'll see in any image, because most images are not seamless unless you make them seamless. So then this is the way you can actually make them seamless in Photoshop. Well, you can push the sides of the image in using the offset function, and then you can either use, let's say, where is it? Like these ones, where's the sampling thing? Yeah, where is it? Yeah, the clone stamp. All right, perfect. So then, what is it again? You can hold Alt, and then we can sample over here, and I can make the brush larger. Yeah, I can just go da da da. So I could be erasing, doing funny stuff like this, and taking my time, making a beautiful transition. So getting rid of that seam. And you can be creative as well. I could just do like this and say, let's get rid of this, and let's have some feathering on this. Like this is pretty large, so something. Oops. Yeah, whatever. Thinking. Yeah, but I'm just gonna put it there, and I can use. Yeah, you could use layer masks, but very quickly I'm just gonna. Everything changed here? All right. So just use a large eraser, no hardness, and I have a layer on top of there, so I could just like be erasing parts of this layer. So you see, I could. There's all sorts of ways. But so this is just one layer on top of the other and pushed to the side, and then I can erase parts of that layer gradually. So that might be also something to do. And then you work it, and then let's merge these, and then you eventually, when you do that, when you do the offset, you will no longer see the seams, right? So now this is crazy because So you keep working. That's how you make a seamless texture. I'm not going to do that. Anyways, so we already have a seamless texture. This is pretty huge. Let's just save a smaller one. So it's a J. Yeah, we could use a JPEG. It's fine. So wood. Let's actually go to the image size. Yeah, let's just do this is a huge. This is a huge one. So typically, if you use tileables, you don't really. They don't really need to be that large. So I could do maybe a 512 one. Tiny little one. I can save this. I mean, if it's larger, you'd have to tile it less. So it's nice to also sometimes have large tiles. But. So wood, fine, seamless. I could 512 if I want to add that. So I'm saving this as a new JPEG, and then I could drag the 512 one Where did I put it? Oh yeah, so I put it directly in the source images. Nice. Then I can go back to Maya and I can go and assign Lambert. As always, I do the file node, I turn off the filter, and I find the would find seamless 512. You can see there it is. Let's have some light coming down here. So if you press number 6 and then press number 7, you're in lit mode. So I just added directional light. So you press number 7, the graphics card is going to do its best to, you see there's no shadows. It's not really great, but it's something. Anyways, so yeah, so this is not yet tiled. It's just that whole 512 texture is just slapped on there. So let's open up the hypershade. And where is it? Lambert 4. I could call it floor shader. So we're gonna again graph the input connections. Oh, I just clicked this one. That's gonna hide all of this stuff. So if you want more place to work with, and then select the floor shader, graph the input connections, and we can see this is the file node, and this is the place 2D texture node, which we so far haven't really touched because usually it just does its job. You don't have to worry about it. But here we're gonna go into the place 2D texture node, which controls the placement of the texture. It opens it up in the attribute editor. And this is the repeat UV function. So we can go like 8 by 8. It's going to tile that texture 8 times across this entire surface. That's it. Basics of tileable textures. So then, yeah, there's various tricks to introducing variety in tileable textures. You would have to do something called vertex painting, which we're not going to be doing. But you can get pretty convincing results by tiling textures. Any questions? See if we can render this. I don't think there's any renders installed. Yeah, they're mental ray probably. But let's just use software and production quality. So just have to turn on ray tracing. Don't need that. So we get some crappy shadows. Yep. Beautiful. Yeah, the crates are beautiful. Look, pretty. Alright, so cool. Let's open up the chair from last time. And I'm going to UV map this extremely quickly. So UV texture editor. What you want to make sure is that all of the objects are, select them, delete history, very important. You don't have any history active for the objects. You freeze the transformations, and you should be good. Okay, so we will not be exploring, so here up here is the create UVs function. This is to make UVs. You can see that the UVs of this object currently still looks like the default layout for the cube, which makes absolutely no sense because it's a different shape. So if I were to assign, okay, so I have to make this Lambert again. Cube. No, sorry, checkerboard. Go to the number 6, and we should see something horrible, which is this. So you can see that, yes, it's very much stretching. The checkerboards no longer look like checkerboards, and that's because the UVs are just crazy. Because after you model, you have to make the UVs, and I haven't made the UVs. This is how you make the UVs in Maya, okay? So what I'm saying is we're not going to be exploring all these different create UVs functions. You can if you want, but we won't, because we're going to be using another software to unwrap. So basically what I'm going to be doing now is I'm just going to do an automatic mapping, which is okay for this, because these are very simple surfaces. So what the automatic mapping is going to do is that you can see, well, we can go into the options for it. So this decides the number of planes in which it will project. So you can see it has 6 planes, so it does a cubic projection. You can see it, it's like it's taking pictures of the mesh and then displaying them over here. So it's looking for continuous UVs. So it's trying to create UV shells for you, right? So it's looking over here and it sees, okay, well, from this angle, I could probably make a UV shell, which is this one, that looks like this, that has obviously that polygon, but it also has those little bevels, right? So that it just does that for you. But sometimes, depending on the bevel and depending on whatever, you'll find that it doesn't really do that. So you'll end up with a lot of little pieces. And that's when this might be a little frustrating. And you can be frustrated with that, and you can try to figure that out, and that's fine. That's good practice when you're working inside the UV texture editor. But I don't want you to freak out about that because, like I said, we're going to be unwrapping in another software. So, but what you might see when you do the automatic mapping is that, let's just try to, if I detach this, so I'm carefully just selecting, the edges here. And then I can go use this one, the scissors, and then I move this little guy over here. So you can sometimes see, if you do automatic mapping, you have a lot of these tiny little UVs floating around. So then you have to figure out, okay, so what is this? If I select this edge, this one will be selected. So I know, okay, so that actually belongs here. So then you can try to squeeze it back. It becomes a little bit of, it's a puzzle. Then you have to figure this out. And then I place it there, and then I want to put it back together. So I shift select these edges, and go and click here, move and sew it together. Boom. Now it's back together. Okay, but it seems like this operation, in this case, did a pretty good job, right? So then I start placing this together. So depending on what you're making. So if you're making a really highly optimized in-game chair and you want absolutely to maximize the UV space, you could nudge these as close together as possible, and then probably you would turn this around, because you see now this goes closer to this one. So you see we absolutely minimize the wasted space. So I would even go in here in the move UV shell tool, and I'll turn off prevent overlap, or set to a very, very, very small number. I typically turn it off because I'm get annoyed with that, and I can just manually make sure that it's as close as I want it, but it's not overlapping. So this is what you do, like I said, if you're doing a very highly optimized asset. But now this is like upside down. It's going to be more work in Photoshop, because you have to go in and make sure that the direction of the wood fibers would match up probably. So it's more work in Photoshop. It's very tight together. So yeah, depending on what you're doing, I typically probably would opt for something like this, where I just place these next to each other logically. So that's another thing with UV layouts. They should be logical. Now they're all the same way. Yeah, I'd probably just do this. Fine. So I'm wasting a little space, but not too much. Okay. And then this could be placed on top of there so it's not occupying more space this way. Fine. So this piece is pretty good. I could probably also just flip all of them upside down. Makes more sense, right? Like that. Now it's pretty logical. And maybe this will occupy a little bit less space if this is down here. Okay. Fine. So I'm done with that piece. I don't have to, I'm not done with the chair, but I'm done with that piece. Let's do this one. So for the sake of this, for time's sake now, I don't have time for this. So I'm just gonna so delete history is very important when you do this. Okay, why is it important? Let's see if this will. No. Okay, so sometimes when you do the automatic mapping, if you don't delete the history, the projection is still active. So when you rotate the object, you'll see the UVs will become messed up. So so I won't spend time on this. Just like randomly here, I'm going to assign the same material, which is the Lambert 2. So this becomes the issue here that we have to address. So I'm just going to isolate these two. So you can see the checkers have different sizes. So now we're dealing with making a UV layout for a multi-mesh asset. We have multiple meshes, but I'm going to try to make one UV layout for the entire chair. So that means I have to make sure that the checkerboards are the same, or very similar at least. So I'm just going to grab these first, and I'm going to move them out here. And I'm going to select both of these. So what you do is just select however many objects you have, and then just click out here in the UV texture editor. So when you select the Move UV Shell tool, these should both still be here. So now I can actually grab all these UVs and I can scale them down. So when I'm scaling them down, I'm giving them less resolution. The checkerboards become bigger, meaning they're actually less resolution because I'm closing in on the image. If I scale them up, the checkerboards become smaller. So revealing more checkers meaning more resolution. Revealing less checkers is less resolution. But I want them to be, pretty much the same. So again, this isn't really super accurate, but you can get it in the ballpark. So when you are working with this, it doesn't really matter where you are in the UV space. So I could leave these up here and just be working. Doesn't matter. Just staying structured. Let's do one more piece, and then I think you get the idea. Hopefully this will be forgiving as well. Yeah, so this is not too bad. Just going to rotate this. So this is the bottom of the seat. If I know that I'm not going to be really seeing the bottom of the seat too much, I could make a conscious decision of having less resolution there if you want to save some space. You can sometimes do that intentionally. Okay, let me just hurry this up. So all these pieces, what I'm thinking is just I'm making a quadratic little layout for all these pieces. So it doesn't matter where I'm working, I could be working here. The whole thought process is just making sure that how can all these little pieces just occupy as little space as possible, right? So that becomes the work. which might take a little bit of time. You have to try this and figure it out, which I'm not going to do now because I don't have time. But so then that little piece could be more optimized, and that's what you spend time doing, right? So let's assign the same material. So this is Lambert 2, and you can see that these checkers are larger, meaning that this piece must have more resolution, meaning I should scale them up, making the checkerboards smaller, getting them in the same. Okay, so the bottom ones are larger because I intentionally have less resolution there. So this is also something like when we use the other software, we don't really have to. It will maintain that texel density all throughout. Okay, so yeah, so I'm not gonna do all these, but let's just hide those. Control H. So let's say this is my chair. You continue the process. You do all the little pieces, and some of these will be repeated. So this is the point I'm gonna make, and then you just have to apply the same logic for the rest of the chair. Or no, because I can copy this mesh now, so it's just going to have the same UVs. Let's do that. So I'm copying the mesh. I'll change the pivot over dx and do -1 or an x. And I'll freeze the transformations, delete history. So it's flipped. So there's a way to see that here. So in the UV texture editor, this little thing will display blue if the UVs are not flipped. If they're flipped, they're red. So this is when you can see that the numbers on the checkerboard is actually flipped. That's why the numbers are there primarily. So if we only had checkers without numbers, we wouldn't see that they were flipped, but now we can clearly see. So we just select the UVs. I mean, sometimes you can get away with having them flipped, depending on the texture. Like if it's a wood structure, yeah, you wouldn't really notice. But if it's something like letters or anything, you might just flip it. So here's the flip option. There we go. So that doesn't really prove my point though, because okay, this by necessity being flipped, meaning they're actually a little bit different. So let's not flip it. I would flip it, but let's not. Let's say it's a wood structure, it's fine, I can get away with it. Just to prove the point that sometimes you can have these objects share UVs. So if you had, let's just do this also for the back. It's great. It's not going to be that way, but let's just do it. So now we have 3 objects sharing the same UV space. That's fine. And that's actually obviously sometimes necessary. If you have a lot of similar objects in the asset, it's rarely the case that they necessarily need separate textures. Sometimes, yes. So if you're making a very high resolution, great hero asset chair, it might become evident that all the legs are actually precisely the same texture. So in that case, you want to consider making 4 different UVs for them. So we would not have them share it. But for the most part, you can get away with having them share the UV space, and then we could even like rotate this guy around, and then that would be a little bit different from this one. Does that make sense? So anyways, so then we have all the pieces where they need to be. So I'm just gonna select all these, delete history, freeze transformations, and then this is all over the place. But now they're to scale. All of them are unwrapped. So now we need to make the final layout. So I'm a little bit over time. I'm going to hurry up and do this in a couple of minutes. So then the thing here just becomes of, okay, we have to make a layout of all these pieces. We have to fit them together in a quadrant. So you can be, again, just be working anywhere you want in the UV editor. So again, you'd spend more time figuring out how can we make this be as quadratic as possible. So the scale here doesn't matter, but what I don't want to do is scale any of these independently of the other ones because we just established the texel density of everyone. They're the same. So we don't want to do that, but we can grab all of them and scale at the same time because this is all relative. You know, it could be large, doesn't matter. But eventually, when you're happy and when you've made that quadratic layout, or if you choose to just do this right away, you can scale it down into here and just be working in here. Now I'm see. So you keep working, you keep trying to make this as efficient as you can, as quadratic a layout as you can. Maybe you change some of these around. Doesn't matter. See what I'm saying? You get this as quadratic as you can, and then you want to make sure you maximize the usage of 0 to 1. So we're inside 0 to 1. So right now, none of the UVs are overlapping per object, per mesh. So none of the UVs in this mesh are overlapping, I hope. Maybe they are. So this is what you have to go in and really be careful. So no, they're not. But they could have been. If I'm not paying attention, for all I know, this could have been there. Now these are overlapping, and this is a problem. It's very hard to see. You have to go over and make sure that they're not, because this could cause problems again when baking. So, and then we don't know, it might give you an error. It's gonna, if you're lucky, you can figure out the UV number, and then, but this will take time to troubleshoot. You're gonna, what happened? You don't know. So that's the point here is that it sounds kind of like we're making too much of a point of being so meticulous about all these little things. The point is that if you're not, and if something goes wrong later, it will be a nightmare troubleshooting and figuring out what went wrong. So this is one of the things you want to really make sure that you don't have overlapping UVs per object. We do have overlapping UVs in the entire asset. We have 3 objects sharing UV space. So that's different. That's okay. We have all these 3 objects sharing the same UVs, meaning they will have the same texture. That's totally fine. So, and sometimes necessary. Okay, so this then, let's say, is the final layout for the chair. It would have had more pieces, meaning I would have had to fit more into here, meaning that the total resolution for the chair might need to be larger than if I have fewer pieces, right? So, and sometimes you can also make an asset with multiple layouts. You don't have to only have one. But what I want you to do for the lab session is that you make a layout for the chair or a similar piece of simple furniture, and you make one layout. And you make sure that you have even texel density, so making sure that the checkerboards look the same. There's no texture distortion, so that's another thing. We can see that all these checkers are looking fine. We don't want any of this happening, which is texture distortion. So as long as your UVs are fine and your texel density is evenly distributed, and you make everything into one layout, which you then just export as a UV snapshot, and you make a simple color texture using Photoshop, then we're good. All right? And then next time we'll start looking at Hedda's UV layout, which is more efficient than this. Yeah, so any questions? Oh, I hope so. we need it. Yeah, we do have licenses for everything, but I don't know if they're currently, they have such a, yeah. Things are taking a little bit longer than usual to get up installed because they're having some issues, I think, with the merger and everything with all these other universities or other schools. Yeah. But yeah, we do need headers by next time. So if we don't have it, then I don't know. We're screwed. I'll get on it and see if. Yeah, it would be nice with Arnold. So. Okay, so don't forget to sign if you haven't signed in, and I'll see you next time. Thank you.